everyone, Amanda Phillips here with my NCTM article share for Module 3/8. The article I chose to read and dive deeper with is called 13 Rules That Expire and was published in August of 2014. Last spring, I had the awesome opportunity of attending the NCTM conference as it was here in Washington, D.C., and I went to this presentation called Say This, Not That, which focused on the importance of correct math language and vocabulary while also chiming in on those tricks that we all use. For example, keep, change, flip when dividing fractions, and why these little tricks aren't the most effective to use with our students. This article reminded me so much of that presentation, so I was really excited when I came across, and I think you'll enjoy it as well. So right away, the author gives an example that really connects to my targeted grade level and topic, which is grade 5, fractions, and decimals. So the example that the author gives is when we're multiplying decimals times 10, 100, or 1,000. So they give 43 and 5/10 times 10, and a child's typical response is, that's easy, because my teacher said when you multiply a number times 10, you just add a 0 at the end, or you just move the decimal place to the right. So from the get-go, children are learning that when they multiply something by 10, and it's a whole number, they add a 0 on the end. If it's with a decimal, they're moving right. But do they really understand why that's the case? And do they understand that it's not the same when it's decimals and whole numbers? So this article suggests that this type of rule expires as students expand their knowledge of number systems beyond whole numbers and then are forced to change their perception. So the remaining pages highlight 13 rules that do expire as students gain stronger understanding of mathematics. I want to highlight a few that can connect across grade levels, as well as focus in on some of my targeted topic. So let's start off by taking a look at rule number 3, because I think this can connect to some of our primary teachers as well as our upper grade teachers. Rule number 3 says you cannot take a bigger number from a smaller number. Yes, how often when we're subtracting across zeros or regrouping do we ask our younger kids, if you have 5 balloons, can I take away 7? Of course, they look at you and they laugh and they say no, and then we teach them to look to the left in order to regroup. However, this rule does expire, and I'm seeing it now with my 7th graders as we review operations with integers. For example, you get $15 for babysitting, but you owe your dad $30. How much money do you have? They're taking that $15 and subtracting a bigger number, 30, which is going to bring them into negative integers. Another rule that I wanted to highlight is towards the end. Seriously, they're all amazing, and they gave me such good eye-opening moments. So please check it out. I think you guys will really like it. But I know many of you teach younger grades, so I wanted to take a look at Rule 13 here. The equal sign means find the answer or write the answer. So the following quote really summed up this rule nicely and can help us better understand the meaning of an equal sign. It indicates that the two quantities on either side of it represent the same amount. It is not a signal promoting an answer through an announcement to do something. In this example, the answer is given, so we cannot say that the equal sign means find the answer, because we have the answer. So this rule, we can see, expires pretty early in grade 1. I could go on and on about this article. I really want to recommend it, that everyone maybe just take 5 or 10 minutes to flip through and take a look at these, because I think you'll have some real aha moments like I did while I was going through it. I loved the examples, and it really had me reflecting on rules that I'm guilty of using or saying. Sometimes it's because I'm feeling rushed through content and I think it will stick better with the kids. Sometimes because I feel like my lower students need a quick trick to hold on to. But what I realize now is by using these rules, it's just a quick fix. It's not helping their foundational and deeper math skills, and it will only confuse them later when the rules expire. Moving forward, I think this article will help me as a math teacher and specialist, because I'll be able to eliminate rules that expire from my own teaching and help my fellow math teachers, I work at an N through 8 school, do the same. I can model and provide resources for them on how to teach the standards conceptually.